Hello and welcome to my science tutorials. In today's video, we want to look at the application of linear equations part 2. So without further ado, let's begin. So let's start with an example. Joe buys 18 kilograms of potatoes. Some of these are old potatoes at 22 cents per kilogram. The rest are new ones at 36 cents per kilogram. Denoting the mass of old potatoes he buys by m kilogram, write down an expression for the total cost of Joe's potatoes. II. Joe pays with a $5 note and receives 20 cents change. What mass of the new potatoes does he buy? Alright, so let's go ahead and solve this example. Alright, so we're told that Joe buys 18 kilograms of potatoes. That's the total mass of the potato that he bought. So let's write that the total mass equals 18 kilogram. Now we're told that some of these potatoes are old and they were sold at 22 cents per kilogram, and then the new ones at 36 cents per kilogram. We were also told to denote the old potatoes by m kilogram. So it means old potatoes in terms of mass is equal to m kilogram. So it means the price of old potatoes, let me make it OP, will be equal to 22 cents multiplied by the mass, because one mass, okay, which is 1 kilogram, is equal to m kilogram. All right, now let's look at the new potatoes. So the new potatoes will be equal to, since the total number of potatoes he bought is equal to 18 kilogram, and then the old ones are m. If we subtract m from 18, we get the mass of the new potatoes in kilogram. And so the price of the new potato will be equal to 36 cents multiplied by 18 minus m, and that will give us the price of the new potatoes. Now, we're told that he paid $4 and he received 20 cents. That means the price of the total mass of the potatoes that he bought will be equal to 480 cents. Because $5, that is 500 cents, and minus 20 cents, that will give us 480 cents. So this becomes the price of the 18 kilogram of potatoes that he bought. Now let's look at the equation. So our total cost over here will be equal to the sum of the old potatoes, which is the price, so it becomes 22m, plus the sum of the new potatoes, that will be 36, multiplied by 18 minus m. Okay, now we know that our total cost is 480 cents. That is equal to 22m plus 36 into bracket 18 minus m. Alright, so now we have an equation. So the first expression, this is the solution for I, total cost. This is the solution. So we have 480 is equal to 22m plus 36 into bracket 18 minus m. This becomes the equation denoting the mass of the potato, both old and new, and then the price. All right, so let's go ahead and solve this equation and get our answer. So if we continue, we have 480 is equal to 22m. Then we expand the bracket over here. 36 multiplied by 18, that will give us 648 minus 36 multiplied by m will give us 36m. Alright, so from here we can go ahead and do our grouping of items. So we have 36 here, we have 22 here. Let me bring the m to the other side of the equal to sign. So I'll have 36m minus 22m to be equal to 648 minus 480. Alright, so 36m minus 22m will give me 14m is equal to 648 minus 480 will give me 168. So I divide both sides by 14. The value of m will be equal to 168 on 14 will give me 12, and that is in kilogram. Okay, so it means the mass m, which is the mass of the old potato, is 12 kilogram. Now if the mass of the old potato, so it means old potato is equal to 12 kilogram, then it means the new potatoes will be equal to 18 minus 12, and that will give me 6 kilogram over here. Now let's look at II. Joe pays with $5 note and receive 20 cents. What mass of the new potatoes does he buy? Okay, so we can already see that after calculating for our mass of old potatoes and we subtract that from the total mass that we have, which is 18, we've obtained the mass of the new potato, that is equal to what? 6 kilograms. So this becomes our II. So the total mass of the new potatoes that he bought is 6 kilograms. All right, let's proceed to look at one more example. We have in 18 years time, Benjamin will be 5 times as old as he was 2 years ago. We have to write this information in the form of an equation involving Benjamin's present age, and we have to calculate how old Benjamin is right now. Right, so let's look at something. Now we were told that in 18 years time, Benjamin will be 5 times as old as he was 2 years ago. Okay, so 2 years ago, Benjamin will be, since we are to represent Benjamin's age with A, it means 2 years ago Benjamin was A minus 2 years. This was his year 2 years ago. Now we're told that 5 times as old as he was 2 years ago means that will be 5 multiplied by A minus 2. Okay, now in 18 years time, Benjamin will be, in 18 years time, if Benjamin's current age is A, in 18 years time Benjamin will be 18 plus A. Okay, now that we've made these deductions from the equation, that the question that we're given, let's proceed to see how we can write this information. So in 18 years time, which is 18 plus A, Benjamin will be 5 times as old as he was 2 years ago. So Benjamin will be equal to 5 times as old as he was 2 years ago. So this is as old as he was 2 years ago, 5 times as old as he was 2 years ago. So this becomes our equation for us to solve. Alright, so let's solve this equation and find Benjamin's current age. Alright, so we have 18 plus A is equal to, let's expand this bracket, 5 multiplied by A will give us 5A, 5 multiplied by negative 2 will give us negative 10. So I will maintain the 18 here and bring the negative 10 to the other side of the equal to sign. It becomes plus 10 is equal to 5A. Then I send this A to the other side of the equal to sign. It becomes A. So I have 28 is equal to 4A. Now 28 is equal to 4A. To make A the subject, I divide both sides by 4. So my A is now equal to 28 divided by 4 will give me 7 years of age. So it means Benjamin is 7 years right now. So if Benjamin is 7 years right now, it means in 18 years time, Benjamin will be 18 plus 7, and that will be equal to 18 plus 7. This will give us 25 years. So in 18 years time, Benjamin will be 25 years old. And let's see whether that is 5 times as old as he was 2 years ago. So that will be 5 into bracket 7 minus 2, and this is equal to 5. 7 minus 2 will give me 5, and this is equal to 25. So we can see that the right hand side of the equation this side, and then the left hand side of the equation this side are all the same, and therefore it means that our answer is correct. So thank you so much for watching the part 2 of the applications involving linear equations. Now I will see you in the next video where we'll be talking about change of subject. So thank you once again, and bye bye.